This programming language is broken. You pour your sundae into 1,000 lines of C, and then some C nerd from his mom's basement obliterates it with just one line. In 2021, researcher Carl Scow discovered that naming a hotspot, something like this, could crash an iPhone instantly. Even simpler strings like this caused the same chaos. Then some discovered that connecting didn't just cause a hiccup, it disabled the Wi Fi completely until you reset the device. This was a classic case of format string vulnerability. To understand how this works, we'll look at some C code. This is the code. Simple, clean. It has a printf function designed to display whatever a user gives it. We know that the printf normally expects a format specifier followed by a value. Now an attacker won't provide a normal string. They'll use a weaponized one. It starts with a unique marker like 4a's followed by a series of %x format specifiers. In C, %x is an instruction to printf to find the value in the memory and display it in hexadecimal format. That's the base 16 number system computers often use. When printf sees those %x formatters, it goes looking for the corresponding variables that it's supposed to print. But the attacker didn't provide any. This is where the vulnerability kicks in. Because it's poorly written, instead of stopping, printf just starts grabbing and printing whatever it finds next in the computer's memory. This is a memory leak. These values look like garbage values, but they are secrets being pulled directly from the program stack. Now for the crucial step, reconnaissance. The attacker looks at the leaked values. They know their 4a's marker is also in the memory somewhere. They just need to find it. And there it is. The fifth value printed is 0x41414141, which is hexadecimal for 4a's. The attacker now knows with certainty my input starts at the fifth position on the stack. This is no longer random, it is a precise location. Reading the memory is step 1. Step 2 is writing to it. For that, the attacker uses the far more dangerous format specifier %n. This instructs printf to count the number of characters it has printed and write that number to the address memory. What is so dangerous, you ask? By combining everything, the attacker now crafts a new payload. They can now use the position they found, that is position 5, to tell %n exactly where to write. By printing 64 empty characters, they can write the number 64 anywhere they have access on the memory. They have full control of writing to the stack. And the final target, the G.O.T, the global offset table. This is the program's master address book, storing the memory location for every function. When the code wants to run the printf, it looks up the address here first. This is the heist. The attacker uses their weaponized %n payload to overwrite the address of printf in the global offset table with the address of their own malicious code. The next time the program calls for the printf function, it's sent to the attacker's code instead. It's a game over. That's how simple string vulnerability leads to a full system compromise. So how do you stop this? The fix is surprisingly simple. It's a golden rule of C programming. Always specify the format. Instead of passing the user strings directly to the printf, you pass the %s as the format and user's input as the second argument. This tells printf to treat the entire user input as one plain string of characters. It no longer interprets any %x or %n specifier inside it. The attacker's payload is completely disarmed and just gets printed harmlessly on the screen. The vulnerability is gone. And that brings us back to the beginning. The iPhone crash wasn't a bug in iOS itself, but a single classic coding mistake in Wi-Fi component. It's a powerful reminder that in programming, trusting user input can be catastrophic. The simplest oversight can bring down the mightiest systems.